complex circuit. A complex circuit is simply one that has more than one resistor. Now, there are many, many ways to hook up more than one resistor in a circuit, but there are two rules that will always work. One is the junction rule, and the other one is the loop rule. For the junction rule, a junction is where two or more currents come together, and the current into the junction has to equal the current out of the junction. It's a pretty simple rule, and it's basically a conservation of charge. If 10 electrons flow into the junction, 10 electrons have to flow out. An example problem for that might look something like this. Here I have a junction where 4 wires are coming together. You can have 3, 4, 5, as many wires as there are meeting. And let's say in this one we have a current of 6 amps flowing to the right. We have a current of 4 amps flowing up this way. In the right-hand wire, we'll have maybe 3 amps flowing to the left. And I want to know what the current in the bottom wire is going to be. So I just make a chart of in and out. And then I look at my 6 amps over here. The 6 amps is flowing toward the junction, so I'm going to say that is 6 amps in. I look at the 4, that's flowing away from the junction, so that's going to be out. And the 3 is flowing to the left toward the junction, so that's going to be in. And I'm trying to find the current down in this bottom one. Well, I have a total of 9 going in and 4 going out, so I simply realize that I need 5 more going out. So I equal 5 amps going downward. The loop rule says that for any loop, the voltage gained in the battery is lost when I go through the resistors. And this is a conservation of energy rule. So when the electrons flow through the battery, they're gaining voltage and gaining energy. And then when they go through the resistors, they lose the energy, and they have to lose the same amount that they gained. So this type of problem is going to look like this. I'll have a battery, and then I might have a loop with, say, 2 resistors on it. And I know that this is a 20-volt battery. And then I hook a voltmeter up to this resistor. And let's say that voltmeter, we'll call this V1 for the first resistor, that voltmeter is telling me that the voltage for that resistor is 14 volts. And I want to know what V2 is. So I'll put a voltmeter around this one. And I want to know what V2 has to be. So as the electrons went through the battery, they gained 20 volts. And by the time they get back, they have to lose 20 volts. So I have 14 for V1, and then they're going to lose the rest of it when they go through the second resistor. So V2 is just going to be 6 volts. So that's a pretty simple rule as well. Now at the top of the next page, we're going to be starting talking about series circuits. A series circuit is one where the resistors are one after another. Just like a series of movies comes out one after the other. The first movie might come out one year, and then the second movie a couple years later. They don't come out all at the same time. You're going to see that there is going to be only one path for the current to take. So the electrons are going to have to flow through one resistor, then the next resistor, then the next resistor, because they don't have any place else to go. It's going to look like this in a diagram. We'll have our battery, and then we'll connect it to one resistor, and then a second resistor, and then maybe a third resistor, even a fourth. But there's only one loop or one path for them to take. Now the rules for a series circuit, if we think of the loop rule, whatever voltage I gain in the battery, I'm going to call that V total. So for the battery, that's going to be V total. V total that is gained in the battery gets lost by the resistors. So that's V1 plus V2 plus V3 plus, and if we have more, we just keep adding them up. By the junction rule, if I look at this point right here, whatever current I have coming out of the battery has no place else to go but to go through the first resistor. So the current coming out of the battery all has to go into the first resistor. It then comes out of the first resistor and goes into the second resistor. So if there's 5 amps of current coming out of the battery, all 5 go into the first resistor, and then all 5 go into the second resistor. So the currents everywhere in the circuit are going to be the same. So we can write that as I total equals I1 equals I2 equals dot dot dot. How many ever I have, they're all the same. Then the resistance rule. If you think about it, the electrons have to fight their way through the first resistor, then fight their way through the second, then fight their way through the third. So the resistances are going to add up to give me the total resistance of the circuit. Now this rule, I'll put a star by it maybe, because that rule is on the reference table. So you don't necessarily have to memorize it, although it's not hard. The other two are not, so you're going to have to keep those in mind as you're doing a series circuit. So here's an example of what a problem for this might look like. I want to find the resistance, current, potential difference in power for each element in the circuit below. So you need to be able to tell me what's the current through the first resistor, or what's the power used by the second resistor. I'd like to make a chart to keep track of things. So for all of my elements, I'm going to have to know V, I'm going to have to know I, I'm going to have to know R, and in this case I'm asking for power. A lot of times I won't ask for power, so we won't have the power in our chart. But for this one we will. And then I make a total for total, 1 and 2, because this time I have 2 resistors. If I had a third, I'd add another column. So I end up with a table that looks like this. And I'm just using that to keep track of things. You don't need to make a table, but I find that it helps me keep things in order. So now I can fill in my givens. My given in this problem is that the total voltage is 30 volts. the first resistor has a resistance of 5 ohms, and the second resistor has resistance of 10 ohms. And now we have to try and figure out the rest of the chart. I'm going to change colors to red, just so you can keep track of the givens and what we figured out. So since we have two resistances, we can use the R rule up here, okay, in order to find the total resistance. So for the total resistance, I just add R1 plus R2. So 5 plus 10 is going to give me 15 ohms for the total resistance. Now, when I go vertically in this chart, I use two equations. I use V equals IR and P equals VI. So for V equals IR, if I was to show all of my work for this one, I would do V equals IR, so 30 equals I times 15, and that's going to give me I equals 2. So now I know my current coming out of the battery is 2 amps. Now for series circuits, if we look at the I rule, the I's are the same. I total equals I1 equals I2. So now I know this one's going to be 2 and this one's going to be 2. Now I can fill out V1 and V2 because I know V equals I times R. So I of 2 times an R of 5 gives me a voltage of 10 for V1, and 2 times 10 gives me a voltage for 20 for V2. And there's always a nice little check. I know the voltages have to add. 10 plus 20 does add up to 30. For the powers, I do P equals VI. So V of 30 times I of 2 is going to give me a P of 60 watts for my power. 10 times 2 gives me 20. And 20 times 2 gives me 40. So the battery is supplying 60 watts of power. The first resistor is using 20 of those watts, and the second resistor is using 40 watts. So here's our last example for series circuits. Okay, for this one, we do the same chart. For series and parallel, we're always going to do the same chart. In this case, I'm only asking for current, resistance, and voltage, and I'm not asking for power. So I can leave the power off. And then total, and there are two resistors, so 1 and 2. Now, I've been given the total voltage. The voltage of the battery is 60 volts. I know that the second resistor has a resistance of 10 ohms. And it says this voltmeter reads 12 volts. So I'm going to write that in here just so we see that, okay? And that's voltmeter is just hooked up across the first resistor. So I know the voltage for my first resistor is going to be 12 volts. Now for this one, I'm going to use the V rule first. I know the voltages add. So V2 plus 12 equals 60. So 60 equals 12 plus V2. And that's going to give me that V2 is 48. So I'm going to write that in here. I'll change colors again to differentiate my givens to the things I figured out. I just figured out that that one there is going to be 48. All right, stop and think for a second. What are you going to do next? All right, see if you can figure it out. What I would do is I, in this column for 2, I know V equals I times R. So V equals I R. 48 equals I times 10. So now I know my current I is going to be 4.8 amps. So I'm going to put 4.8 in there for my current. Now for a series circuit, once you know one current, you know them all because the currents are the same. So it's going to be 4.8 here and 4.8 here. Now to get the resistances, since V equals IR, I can rearrange that. R is V over I. So if I take my voltage of 60 and divide it by 4.8, I'm going to get my resistance. And if I plug that into a calculator, I end up with a resistance here of 12.5. If I take 12 and divide it by 4.8, I get 2.5. And again, we have a check. The R rule says the resistances should add. So our resistor 1 of 2.5 plus a resistor 2 of 10 gives me a total of 12.5, and it matches what we got in the chart. So we know we did it correctly.